Hello everyone, this is Robert. So I've had this idea for the past year or so. I wanted to make indoor wind chimes, okay? So I made some wind chimes a long time ago and they're pretty cool. You know, when the storm rolls in, we're kind of on the eastern plains of Colorado-ish. And when storms roll in, you start to hear the chimes and you kind of, over the last year or so of having them, once you kind of hear chimes in the distance, you're like, ooh, there's going to be a neat storm that's going to roll in. And we kind of have this mountain view to where you can kind of see the storm coming in. So the whole idea is if you can take those chimes and bring that mood and concept inside, then inside the house you can kind of get this same mood and feel. Like I really like having those windy, blustery days, and having that mood inside would be interesting. So I've been working on this project for at least 6 months, and it turns out it's actually really challenging to have essentially musical instrument inside your house that organically reacts to the wind outside of your house. So what I want to do in this video is kind of give you an overview of the project. I'm still kind of in the prototyping phase, but I'm moving into the actually making it phase. So in this video, I just kind of want to show you all the little challenges and hiccups that I've run into along the way and kind of how I've seemingly overcome those. So yeah, this is going to be the start of the indoor wind chime project. At this point in my YouTube career, I've done enough videos to know when people kind of drop off of the video, and I know that this is kind of outside the normal scope of my channel. But if you're still watching this video, I would say give this one a chance because there's a lot of interesting aspects to this project. This is really just a design project more than anything. It doesn't matter if it's wind chimes or what it is, but from my testing, what we're going to end up with is an outdoor weather station with a large CNC machined platform with nylon carbon fiber truss structure holding these massive chimes that are controlled by a carbon fiber striker system with an electromagnetic actuator. This got really complicated. So what I want to do in this video is kind of give you an overview of how I decided on each one of these individual components. There's basically 5 main pieces to this project. We've got the outdoor weather station, the chimes themselves, the electromagnetic striker system, the electronics, and then also the kind of overall structure and mounting. And each one of those has its own set of challenges, and I'll be making a video or a series of videos for kind of each one of these pieces because each one is kind of its own project in its own right. But in this video, I just kind of want to give you a brief overview of why I'm choosing what I'm choosing and how I decided to like kind of these 5 components for it. So let's go ahead and get started with the outdoor weather station. When I first came up with the idea for this, I was thinking that I could just kind of go on Weather Underground or something like that and pull down weather information and go from there. But what I quickly realized was that every location's very different. You know, I could get this big gust in my yard, but like 2 blocks away, it might actually be not that windy. I need to perfectly understand what the weather is doing in my backyard or, on my property. So that meant I have to have a weather station. That seems kind of easy, but then you realize, well, it might be dark out when it's storming. So okay, it's going to need some kind of battery system. Well, then it's going to need a solar system. So what I ended up with is the outdoor weather station that has a wind sensor on it that feeds into an Arduino with a SparkFun weather shield on it. And then you also have a solar charge controller, a solar panel, and a large sealed lead acid battery. So that whole thing can sit outside indefinitely, collect wind speed data, and it's powered by the battery, but then the solar can recharge it, so I don't have to worry about, it always being in the sun, whatever. So battery backup system, and then it sends it inside to an Arduino here with one of these cheap RF modules, these little RF transceivers that you can get on Amazon. And I posted this on my Instagram a while back. This was kind of one of the first things that I ended up building. And the critical key to this that I learned is I need wind gust speed, and then I need an average. So if you kind of sit down and watch chimes for any length of time, what you realize it's the chaos that you ultimately want to replicate. But when a large gust of wind comes through and then just kind of dies away, That's interesting, but it really doesn't make the chimes do a whole lot. But if it's really consistently windy, that's kind of what gets them really moving. So you need to kind of pay attention to both. And I'll talk about that in the code and electronics later, how I'm translating that into, the analog of actually moving the whole thing around and making sound. But ultimately what I came down with is I need an outdoor weather station on my property that measures the actual current wind speed and also gives me a wind speed average. So here we have 4 of the 6 chimes. These are aluminum tube. It is 1.5 inch outer diameter and an 1/8 inch wall. And the largest one is about 6 feet. And then we go down to around, I think, somewhere around 4 feet for the smallest one. And you kind of got to pick a chord. And if you watched my other chime video, you kind of heard how you do this. But so that is kind of what the chord will sound like. And the way that I make these is you basically get the raw material and then you chime it. I actually made these little suspension mounts out of 3D printed and some rubber bands. And then you record it into a microphone, do a spectrum analyzer to actually look at that, look at the nodes along the frequency spectrum, and then just basically cut them down to length and get them all nice and tuned. And you'll see they have these mounting holes in them, and these are, I think it's something like 22.5% down from one edge. If we do this, you can see that is basically the dead spot in each one of these chimes. This is where the waves will kind of cancel themselves out. So when you mount them at these points, then the actual mounting won't deaden the chime. If we mounted them, let's say at the end, it just silences them. But we can mount it here and it doesn't actually deaden it. So that is the chimes, and there's 6 of these total. So now that we have wind speed data and we have 6 chimes all tuned up, how do we kind of interface those things and get them to do the thing? Well, this was actually relatively challenging. I tried a lot of different methods because I was originally thinking of having these kind of flat against the wall, and you'd maybe just have strikers or electromagnets or something hitting against them, solenoids, and I kind of thought, like, what would it be like to have piano strikers? Well, the problem with that is the way a normal wind chime works is one strike can actually hit one and then bounce off and hit a couple others, so there's that kind of chaos between there. And I could have maybe programmed this into the microcontroller on the receiver side to where when you hit one chime, it knew which ones were neighboring and could kind of hit those a little bit quieter. But I ultimately decided that having just a traditional striker swinging in the middle was the best way to go. So what I'm going to do is have 2 opposing electromagnets, this one on a striker, or well, one of them on a striker, and it will pass down and they will oppose each other, and that is what will actually create that striking motion. So it will act like a traditional striker in the middle moving along, and it will just oppose to the other electromagnet. The thing that I ran into, though, was that if you just kind of have them always on, it will just kind of skip around the outside of it, so you actually need to pulse it on and off. This is where our wind speed data comes in. We have 2 variables. We have the actual instantaneous wind speed, and then we actually have the average wind speed. The average wind speed will actually equate to the time, the dead time in between when that electromagnet is on or off on the bottom and the top, because they're basically controlled the same way. So it will be pulse, pulse, pulse if it's low wind speed average, or if it's really, really, really consistently windy, it'll pulse, 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 but you need that pulse to actually push away, and then the power that it pushes away from and basically the level at which it's pulsing will actually then be the instantaneous wind speed. So if you get one gust, it'll just kind of boom, pop out, and that's about it. But if consistently windy, it will be always going, and then the more wind there is, or the higher the wind speed is, then it will be very, very forceful. And the beautiful thing about all of this is these are just variables that get mapped to each other. So if you want this thing to be quieter or louder, you can essentially have a volume knob by just changing the range of those variables. I think this thing's going to work on like a 24-volt system for the solenoids, so I can just kind of vary that down, much the same way that you would drive motors. I'm actually going to be kind of using motor drivers to drive the electromagnets. So by controlling it like that, you can control how much force there is, and then you can just kind of quiet it down by lowering that value. For the electronics for this whole project, you have two distinct pieces. You have the outdoor weather station, which I've shown, and then the inside piece. I haven't fully worked all of this out yet, but you're going to have something that needs to drive the electromagnet, and then something to also kind of interface with the user. I don't want these going in the middle of the night. I want there to be a mute button. I want there to be a volume button. So I'm not really sure where and how I'm going to integrate this. I might actually integrate it into my home assistant system to where you could have like kind of quiet hours. It could actually look at your alarm, and if you have an alarm coming up, it could turn that on and off. There is some interface. You could make this with a very simple on and off switch to where you just turn it on when you want it to be on, but I think that kind of removes some of the point. And then you could also have just kind of a volume knob thing. But I might like it to where if we're watching TV, maybe it's quiet, things like that. So there's going to be a lot of decisions to be made from there, because this is going to be relatively central in the house. And it can get relatively loud when it's on full, and I kind of want that as the background sound, but being able to kind of control that, mute that, maybe when the phone rings, something like that, you want to be able to hit that mute button, just have it turn off. So there's a lot of little considerations there which I haven't fully worked out. I've just kind of thought through a little bit. And lastly, we have the structure, how this whole thing is going to be put together. Because like I said, it's going to be 6 to 7 feet tall. It's going to be, pretty large, pretty heavy. And I want this kind of mounted on the wall. We have this stairwell going downstairs, and there's a nice big vertical spot that it would sit nice on. So I need to have a method to have 6 chimes in a circle. This isn't going to be hung from a ceiling. I originally did think about just kind of hanging it, but the big problem with that is inside you don't really want them just kind of swinging freely. You want them fully captive. So I came up with some of these 3D printed arms, and I'll have kind of a video as I'm talking that shows how these work. But right now the prototype is to have these arms attached to an 80/20 extrusion rail, and it basically, you have kind of these medium ones, you have these small ones like that, and this will actually move them into an arrangement like a hexagon, I guess that is hexagon. It'll move them in kind of a hexagonal arrangement because you want that striker to be equally spaced. So the idea right now, I don't have any of this modeled up, but I would have a large spine, if you will, which, 1/4 inch, 3/8 inch panel of aluminum, and then you have these arms kind of coming out from it, and then those chimes are hanging kind of in this hexagon pattern, and then you have the striker down in the middle, and that whole assembly just kind of bolts into the wall. One of the challenges that I ran into is how do you hang these? And so what I ended up coming up with is a rubber band suspension system. I don't have any rubber bands in front of me. You basically have a rubber band that goes through these mounting points, and then there's a little dowel pin slot that clicks in. So you just have a little dowel pin that clicks in place, and then it'll have a rubber band across this gap, and then they are held nice and suspended. They can chime really nicely, but they can't go anywhere. They're completely fixed in place, as you can see in this video. So that gives them that kind of rigid mounting, but with a little bit of compliance so that they can still ring, because I don't want them actually clanging into each other like real wind chimes would be. So I think that's all I've got for this video. I'm not exactly sure what the next step is. I've got to 3D print more of these and kind of mock up the main structure. It's this weird chicken and egg thing, because I knew I could make the chimes, but I needed to see if I could get the electromagnetic clacker thingy working, and I got that going. Then I needed the weather station, got that going. Now I kind of have all the pieces I need. I just need to start making it and start designing things in SOLIDWORKS. There's still a lot of little issues, like you got to hit them all at roughly the same spot. They all want to be hit within 5% of the bottom. So that means they got to be kind of staggered really weird, so it makes the mounting really strange. They're all going to be at very different heights. So there's still some stuff left to figure out, but I'll be making periodic updates, so be on the lookout for those. Thanks for watching, and I don't know, get into wind chimes. They're kind of cool. This will be an interesting little project, and I'm very much looking forward to it being done and kind of up on the wall. And because right now I have no idea if this is even going to be interesting or cool. It might just be really annoying. Who knows? We'll see. But thanks for watching. See you in the next video.